Hi everyone, in this video we are going to talk about how to name our molecules. So IUPAC, the International Union of Pure and Applied Chemistry, came up with nomenclature, which is just how do I name my molecules? So it's this standardized way, this set of rules that we're all going to follow. We will have these rules be implemented throughout the entire semester and including into Orgo 2 if you take Organic 2. You want to know all of them now, but I will tell you for the quiz, it's only going to involve simpler molecules for quiz 2. So the quiz this weekend is only going to involve hydrocarbons, meaning that there are not going to be any primary functional groups, and there aren't going to be any secondary functional groups. You can get substituents though, and you will have the backbone. There will not be stereochemistry. So for quiz 2, it's just going to be naming hydrocarbons. That's it. So to name our molecule, our names are always going to have this general setup where we're going to have our backbone is made up of a root and a parent functional group. Our primary functional groups, there will only be one and only one primary functional group ever. And sometimes there might not be any. There might be 0 primary functional groups. Every other functional group would then become a secondary functional group. And all of our substituents, which are going to be like hydrocarbons and halogens, those will be substituents and they would come out front. And then our stereochemistry would come all the way out front. So starting out, the first thing you want to do is identify the longest possible carbon chain. That is your backbone. So you want to try to highlight as many carbons as possible to try to find the longest continuous chain of carbons. Note that it might not just be left to right. It might go right to left. It might go down, up, and around. It might loop around. You got to make sure that you're looking for all possible longest paths. Once you find your longest path, then you need to count how many carbons that you have, and that determines your root. So your roots are 1 meth, 2 eth, 3 prop, 4 bute, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, 10 dec. These 10 you need to have memorized. I will expect you to know those 10. Additionally, the first 4 have abbreviations. So our methyl gets abbreviated ME. So meth can be abbreviated ME, eth can be abbreviated ET, prop can be abbreviated PR, bute can be abbreviated BU. These tend to confuse students because they look like elements, having that one capital letter, one lowercase letter. These aren't elements. These are abbreviations of multiple elements. The rest of these, you mostly just want to be aware of the fact that they exist so you can interpret them, but it's the first 10 that I'm going to expect you to be able to do number to root, root to number, going both directions. So what this looks like is if I were to go left to right, and that's usually how I start, is I go left to right, and then we'll check myself and go right to left, or I'll just try all the different ends. So starting left to right, I would get 1, 2, 3, 4, 5, 6, 7. So highlighting here, I can highlight 7 carbons without picking up my pen. If I just go straight left to right, I get 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 carbons, highlighting across. So that is fewer. So that is not my backbone just going straight across. I had to go up this way. If I were to check up here and I go 1, 2, 3, 4, 5, 6, that is still 6 carbons. That still is not my backbone. So I want to check all possible pathways. The longest one determines my backbone. Then you're going to make sure that your backbone contains the maximum number of bonds, meaning that if there's a double or triple bond, try to include as many of them as possible. So in this case, because there's an alkene, I'm going to go up this way to make sure that I can include the alkene. I won't go straight across. That excludes the alkene. The alkene, remember, that indicates that it's the double bond, that carbon-carbon double bond. If there are 2 equal length backbones, choose the one that gives you the greatest number of substituents. You want to avoid the branch substituents. So here, I'm going to come across and down because that gets me these 2 substituents that are not highlighted, and they are able to be highlighted in just one stroke coming off of that backbone. A branch substituent is one that when you come off the backbone, you then can't highlight every carbon. That's an additional branch. That's a branch substituent because it's like a branch of a branch coming off that tree, coming off that trunk, that backbone that is our structure. So you want as many substituents as possible. If there's a ring, that is your backbone. So this is a rule that changed in 2021, I believe, is when they instated this rule, that it no longer matters how many carbons you have. It is the fact you have a ring, that becomes your backbone. Also, if you have a ring, you're going to use cyclo as a prefix that is going to describe your root. So it's going to be right next to the root. It is right there directly modifying it because it changes the composition of your backbone. So here, the ring is my backbone, that 3-carbon chain. Even though this is a longer chain and it has the double bond, doesn't matter. Ring always takes priority. Rings are always going to be the true backbone. All right, so now I have my backbone. Now I need to figure out my parent functional group. My parent functional group determines the bonding in my backbone. So it's still modifying my backbone. It's saying what type of bonds do I have? If I have all single bonds, I am the alkane. And then I'm going to take the AN or ANE suffix. If it's an alkene double bond, I'm going to use the EN or ENE. Alkyne, I'm going to use that YN or YNE. You will only choose the alkane if there is no double or triple bond. If you have a double bond or a triple bond, you automatically become the alkene or alkyne. Alkane is that bare minimum to be an organic molecule. We're not going to use alkane as our parent functional group unless there is no double bond or triple bond. This is just saying that if you have no primary functional group, then you just put an E here. If you do have a primary functional group and the next letter is a vowel, then you would drop the E. So basically, no primary functional group, use ANE, ENE, YNE. If you have a primary functional group, you'll most likely be using that AN, EN, or YN. If you have both double and triple bonds, then you want to have both EN and YN present to indicate that you have 2 types of parent functional groups, the double bond and the triple bond. The EN gets listed before the YN because of alphabetical order. We're going to see that alphabetical order is going to be one of our final tiebreakers for us. So between these, we're going to use that alphabetical order. E comes before Y. That's why the double bond gets listed before the triple bond. So this is 6 carbons that are all single bonds. That makes it a hexane. Here I have 6 carbons, so it's still hex for 6, but I now have a double bond, so it becomes ene as my parent functional group. Once you get that parent functional group, because that double bond or triple bond could be located anywhere, you need to put the number indicating the location of it in the backbone. You will always use the smallest number. So, and your numbering will always go through that double bond or the triple bond. So this becomes hex 1-ene, hex 1-ine. And then here I get 1, 2, 3, 4, 5, 6, where it is hex 1-ene, 5-ine together, all combined. And it's because you're taking the smaller number of the 2 that describes the location of the double bond or triple bond. With our double bonds, we're going to have stereochemistry. So the double bond is that locked conformation. So you can have the kind of a top side and a bottom side, essentially. So they're going to be different sides. And we're going to need some naming convention to tell us which side is each substituent located on. So our double bonds are going to have a stereochemistry assignment that is going to be either cis or trans or E or Z. The priority of the substituents is based on Coningle-Prelog rules, CIP rules, and it is based on the higher atomic number is the higher priority. So that is the ranking. In the event of a tie, then you use the higher atomic weight, meaning that isotopes will have a higher priority. So heavier isotopes will have a higher priority. The main one to watch out for is deuterium will be higher in priority than hydrogen. It's kind of the main one. Cis or Z means that your highest priority are on the same side of the double bond. Cis meaning same. Z is from the German word zusammen, which means together. Trans or E means your highest priority are on opposite sides. So trans is coming from the opposite. And then E is, and again, I don't speak German, I'm sorry, which meaning opposite. So cis and Z are same side, trans and E are opposite sides. So when I look at this, go one side at a time. So I'm going to start with one side of the double bond. So I'm going to ignore the right side and only look at the left side. I am told that my priorities are that A is higher in priority than C. That's what that little key is telling me. It would have been based on the atomic number. So A is higher in priority than C. So that makes A high, C low. Cool. Now I look at the other side and I disregard the left side. Now I'm only going to look at the right side of the double bond. B is higher than D in priority. So B is high, D is low. Now I connect the dots. I go through that double bond, connecting the carbons of the double bond. My high priority is on the same side, that is cis or Z. If my high priorities are on opposite sides, when I connect those dots, then it is trans. That's opposite side. We're going to only use cis and trans when our alkenes are 1,2 disubstituted. Substituent meaning non-hydrogen. So that means that I have a non-hydrogen just on each side. Or you could think about it as you have to have one and only one hydrogen on both sides. So cis would look like that because I have to have one hydrogen and only one hydrogen on each side. And then trans would be that because now they are on opposite sides. E and Z are used for our tri and tetra substituted. Or there is other stereochemistry. So other stereochemistry will involve R and S assignments. So if you have chiral atoms using an R and S assignment, then you have to use E and Z as well. So we will just use the same convention. If same one letter convention. Otherwise, you would just do cis and trans if it's 1,2 disubstituted, or E and Z if you are tri or tetra substituted. So looking at this, this is a cis hex 3-ene. This is a trans hex 3-ene because I'm looking at the higher priority groups and they're on opposite sides. This is a 1,2 disubstituted because I have one and exactly one hydrogen on each side of the double bond. This is tri-substituted because now I have 3 groups. And the reason that this group is higher in priority is because you must go atom by atom until you find a difference in your atomic number. So when I'm comparing these two, I go atom by atom. So off my carbon, I find a carbon. Off that carbon, I find another carbon. That is a tie. So now I go off of that atom. So off the carbon on the top, I get 3 hydrogens. Off the carbon to the bottom, I get 2 hydrogens and a carbon. Now, all of a sudden, I'm at the higher atomic number. That makes this the higher priority. So you go atom by atom until you find a difference. And then the higher atomic number makes you higher priority. That's why this ethyl chain, the 2 carbon chain, eth for 2 carbons, is going to be the higher priority chain. So high priorities are on the same side when you draw a line through that double bond. That makes it Z because now it's tri-substituted. I cannot use cis or trans. I must use Z. You can either put Z all the way out front, or if you include it in the name, then you just do the number for the location of the alkene and then the parentheses of the letter Z. Cis and trans may never be in the middle of the name. You can only have E and Z in the middle of the name. Then for our this next one, now they're on opposite sides. So now I have to use E for the opposite. And if I have multiple alkenes with multiple stereochemistries, I'm going to use the number location of where that starts. So when I number this, I see that I have the alkenes starting at carbon 2 with my high priorities are on the same side. So that is 2Z. And then here I have my high priorities on opposite side for carbon for the alkenes starting at carbon 4. So it's a 4E. Once you have identified your backbone, you then are going to identify your substituents and your primary functional groups and all functional groups. So side chains are going to be carbon chains that are not a part of the parent chain. So they're one of the branches. So these are alkyl or aryl groups that are coming off. They will always have that suffix YL to tell you they are a substituent. They will use the same roots as the backbone, but they have YL as your suffix. They don't use the ane, ene, or ein. Well, they will use ene or ein potentially. They always end in YL. So to clarify that, now that I said it, if that is my, let's do it that way. No, let's whatever. If that is my substituent, then it would be an eth for 2 carbons, ene for the alkene that is there, and then YL because it's a substituent. So that's how you would name it if you have a double or a triple bond. You do include the ene and ein in the substituent name, but it must always end in YL. YL tells you it is a substituent. Certain branch substituents will have different prefixes. N for normal, meaning straight chain. Iso is going to be for the Y shape. Sec is when you have the methyl located at the first carbon closest to the true backbone. And tert is going to be when you have these 3 methyls all connected to the same carbon, making a quaternary carbon. So if I have a 1 carbon chain, it is just methyl. 2 carbon, ethyl. 3 carbons is propyl, or it could be isopropyl if it is this Y shape. So it would look like that, would be as the line diagram. If you were naming it with the branched naming convention, which is the naming convention I want you to use, you need to be aware of ISO, but you need to also be able to know how to name it using branched naming convention, which is you're going to use parentheses to name this. So this becomes 1-methyl ethyl. Because you're going to have your numbering of your branched substituent start at the true backbone and go out. So you always have to start closest to the true backbone and then highlight out as many carbons as you can. So that makes this a 2-carbon substituent coming off the true backbone. Off of that, I find this, whoops, 1-carbon substituent, so a methyl. It's a 1-carbon substituent on a 2-carbon substituent. It is attached at carbon 1 of my branch. So the 1 goes in the parentheses. The parentheses are representing that entire branch substituent. So everything on the branch substituent goes in parentheses. The location of the branch itself, where it is, whatever carbon it's on here, would go outside the parentheses. Inside parentheses is locating on the branch. Outside parentheses is for the true backbone location. And the backbone of the branch will always be closest to the name of the true backbone. Our butyl is where you get this straight chain, 1, 2, 3, 4 carbon straight chain. That's N-butyl. Sec-butyl is where you have the methyl attached to carbon 1. So this would be 1-methyl propyl. Isobutyl is a 2-methyl propyl. And that's, again, we're seeing that Y shape. So that's the iso. Tert-butyl is going to be a 1,1-dimethyl ethyl. And it looks like that little 3 lines sticking out from the center. Phenyl is when you have a benzene coming off. So to represent the benzene as a substituent, you would call it a phenyl. So when I name this, I find my longest carbon backbone, and then I would have heptane for the 7 carbons, and then methyl is for that 1 carbon substituent. Then I would get the 8 carbon true backbone. Then I have an isopropyl and my tert-butyl. There is one and only ever one primary functional group. Your hydrocarbons, halogens, and ethers will never be your primary functional group. They're always going to be a secondary or a substituent. They always go out front. And they're named they would be named at the beginning. Your primary gets named at the end, after the root. There can be as many secondary functional groups as you need. That's just everything else becomes a secondary functional group. They're always going to be at the beginning of the name, and they're going to use the prefix, and they'll be listed in alphabetical order. So your primary uses the suffix. Your secondary uses the prefix. So that just tells you which column you need to know. You need to have all of these memorized, not by quiz 2, but eventually by the first exam, you need to have all of these memorized. You need to know the functional group, what it looks like, because you should know your functional groups, your prefix and your suffix. The prefix or the suffixes that I want you to use, because sometimes there are multiples, I want you to use that oic acid or the O8 for your ester, amide for the amide, nitrile for the nitrile, all for the aldehyde, and one for your ketone, all for your alcohol, OL, not AL, thiol for your thiol, and amine for your amines. For your prefixes, you will never need to use the carboxylic acid prefix. You also never need to use the ester prefix, nor the amide. You do need to know cyano. You need to know formyl and oxo, and we will talk about when you use which of those. You need to know oxo for ketone, hydroxy for the alcohol, sulfonyl for the thiol, amino for your amine. For your ether, you're going to use the root telling you the length of that side chain. It's going to be whatever's the shorter side of the oxygen, and then it's oxy. So it'd be like methoxy, ethoxy, propoxy are your naming of your ethers, and then for each of your halogens as well. So these are always substituents. These are never going to be a primary functional group. That's why they don't get a suffix. Everything else is in this order. So this is decreasing order of priority. So if you have a carboxylic acid and a bunch of other stuff, cool. Carboxylic acid gets the suffix, everything else uses the prefix. If you have a nitrile and a bunch of other stuff, then you use nitrile suffix and the prefix of everything else, right? So that's how it works, is whatever's highest up on the list, the highest up suffix gets used. Everything below, you use the prefix. Next, once you've identified what all of the groups are, so first you identify your backbone, then you identify what your functional groups are, what your substituents are, and you name them. Now you're going to group your repeating substituents and functional groups together. If there are 2 of them, you use di, 3 becomes tri, 4 tetra, 5 penta, 6 hexa, so on and so forth. These are using the same prefixes that you use for your molecular compounds, like how there's carbon dioxide. So that is that 2 for di. So you need to know both of these prefixes. that, or you need to know the prefix as well as the root. A lot of students get tripped up on 4 for some reason, where they mix up tetra, meaning 4 of something, and bute, meaning 4 carbons. So bute is just for that carbon backbone root. So when I'm naming this, because I see that there are 3 methyls, that gets combined to be a trimethyl. Then all of the numbered locations get grouped together out front. We'll talk about numbers in a hot second. With 2 alcohols, they get combined to be a diol. And you again list the numbered locations right next to where they're located. All of the substituents out front get listed alphabetically, ignoring the prefixes. You ignore the di, the tri, the tetra, all of those you don't consider. You only consider the M of methyl, the root, what the actual functional group is, or what the actual substituent is. So when naming this would become the triethyl. The E goes first in the alphabet, so it comes first, then dimethyl because it's for the M of methyl. When assigning your stereochemistry of your stereoisomers, the RNS assignment, it uses the exact same rules as your cis and trans alkenes or your E and Z alkenes. It's using that con-angle paralog, again, based on higher atomic number. And you go out until you find a difference, until you find the difference in your atomic number. You are going to, instead of having the dividing line, because it's not a locked conformation for a carbon that has 4 different substituents for an sp3 hybridized carbon, we're going to instead be assigning a clockwise or counterclockwise. We're going to find that clockwise is R, counterclockwise is S. That is when your lowest priority is on the dash. So when the lowest priority is on the dash, then I'm going to connect 1 to 2 to 3 for the ranking priorities. If that is clockwise, it is R, counterclockwise S. So when I look at these examples, I have the highest atomic number is going to be oxygen, followed by nitrogen, then carbon, then hydrogen. So hydrogen is on the dash, that's the lowest priority. Then I connect 1 to 2 to 3, that is clockwise, so that is R. When I flip these and I get 1, 2, 3, 4, so that now when I connect 1 to 2 to 3, it is now counterclockwise, that makes it S. And that again goes all the way out front, using that same con-angle paralog priority numbers. We will talk about our stereochemistry a lot in a couple chapters. I think chapter 5 is when we talk about stereochemistry. So we'll talk about other strategies for assigning R and S a lot. I don't expect you to know that for this quiz. You do need to know it for the first exam, though. Next, we need to identify the location of our substituents. So we have identified our backbone. We then identified all of our substituents and how to name them. Now I need to give them numbers. Now I need to give them a location on the backbone. You must first start at the carbon that will give the primary functional group the lowest numbered position. So if you have a primary functional group, start as close to it as possible. So here I can number this right to left, or sorry, left to right or right to left. Looking at the primary functional group is that alcohol, 2 is less than 4. So I'm going to name it where the alcohol has the 2 and everything else gets numbers based off of that. The alcohol decided, the primary functional group gets to decide first. If you don't have a primary functional group, or if there is a tie, then you're going to get the smallest combination of numbers. So you then base it off of that combination of numbers. So when I look here, where all of my substituents, no matter what, the alcohol is always on 3, then next, well, the multiple bonds needed to be next, I'm sorry. So it's primary first, then basically you're going right to left. So it is the primary functional group first. If that's going to be the same number no matter what, then you consider the parent functional group. And then in the case that if that's still a tie, or if you don't have a parent functional group, or rather if you don't have a double or triple bond, then you are going to do the smallest combination of numbers. So here the alkene was my deciding factor. Here I see that no matter what, the alcohol is always 3, and no matter what, my alkenes are always going to be a 1 and a 4. So now my combination of numbers is looking at everything else. I have a thiol attached to carbon 1 and an amine attached to carbon 2. If I numbered it right to left, I get the amine attached to carbon 4, the thiol attached to carbon 5. When I compare these, you go left to right to find the first difference. That 1 is less than 4, so that is the number that we take. That is why we numbered this left to right. In the event that that is still tied, then we are going to use the alphabet. So it is primary functional group, then double and triple bonds, then the smallest combination of numbers. If that still doesn't give you a deciding factor, now you use the alphabet as your last ditch effort to just sort this out. So using the alphabet, that's what helps me know, because no matter what, now my alcohol and my amine are always on 1 and 5. Their locations are always going to be a 1 and a 5, no matter what. So my tiebreaker is the alphabet. A of amino comes before the S of the sulfonyl. It's important to note that it's not based off the name of the functional group. It's based off of how it's named in the IUPAC nomenclature. So it is the S of sulfonyl, not a T of thiol. So A comes before S, so that is the name. Now you're going to assign the location, and you're going to put the numbers directly in front of whatever they describe. So if you have the number, or whenever you list the number, our numbers are always going to be separated from our letters by hyphens. If you have multiple numbers, they're always going to be listed in increasing order, and they are separated by a comma. There are no spaces in this. So we list the numbers starting with the lowest first, separated by only a comma. So here I have 2-methyl, so it becomes a dimethyl, and it's a 2,2, 2,2 dash to separate the numbers and the letters, dimethylbutane. This becomes a 2,3 dimethylbutane. This is the type of naming I expect you to be able to do for the quiz on this weekend. So when we bring this all together, we get our backbone is here with the root. You could have cyclo describing the root if it's in a ring. We are then going to have our parent functional group with its locant number if it's an alkene or alkyne. E and Z are used if it is a double bond with stereochemistry. Your primary functional group is all the way at the end with the suffix and the number going directly in front of it. Substituents and secondary functional groups are listed out front with the decreasing priority, they're listed alphabetically. And all the way out front, we get our stereochemistry of the R and S, or is E and Z. So what that looks like is if I have this molecule and I'm trying to bring this all together, I start by finding my backbone. I find that this is going to be my longest carbon chain. Those are 10 carbons. So I'm going to use the deck as the root for my backbone. Then I see that there is an alkene. That tells me that my parent functional group is going to be an alkene or ene. It is going to be located at carbon number 3. The deciding factor is based on my primary functional groups. So if I number this first, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, left to right, I see that my alcohols are a 5 and a 6. Right to left, it's still a 5 and a 6. So primary functional groups went first. Then I'm going to go on to my alkene because I do multiple bonds next. The alkene is going to either be a 3 or a 1, 2, 3, 4, 5, 6, 7. 3 is less than 7. That says I have to number this right to left. I have to use these numbers. So that takes care of my backbone and my primary functional groups. Actually, I didn't take care of my primary functional groups. The alcohols, because that is the highest priority present, it's the only primary functional group or functional group capable of being a primary. We take that OL of the alcohol. Because there are 2 of them, I use the di prefix multiplier. And then they are located at 5 and 6. So it's 5, 6 hyphen diol. Always use a hyphen between your letters and your numbers. Next, I'm going to name my substituents. So these carbon chains that are hanging off. My 1 carbon substituent becomes a methyl, meth for 1 carbon, ol, the YL, because substituent. This is a methyl, 1 carbon substituent. This is ethyl, a 2 carbon substituent. The meths get combined to become a dimethyl. located at 4 and 7. So it's a 4,7 dimethyl. The E comes before the M alphabetically. So I get a 7-ethyl. When I look at the stereochemistry of my alkene, my high priorities are on the same side of the alkene. So that makes it Z because it is tri-substituted. That goes all the way out front. All right, there are a lot of extra rules. There are a lot of extra practice on Canvas. If you have any questions, please let me know. And just to further clarify for the quiz this weekend, I do not expect you to know how to use the primary functional groups or secondary or any of those suffixes. All I'd expect you to be able to name are those hydrocarbons. So if I gave you something like this, then I would expect you to be able to recognize, okay, here's my longest carbon chain. I can number this left to right or right to left. Because there's no primary functional group nor any double bonds, I'm going to number this based on the smallest combination of numbers. So my substituents are located at 2 and 3 or 5 and 6. 2 is less than 5. So that means that I'm not going to use 5 and 6. I'm going to use my red numbers. I usually recommend then erasing the wrong numbers. That way you don't confuse yourself. So then I have my root is going to be hept for my 7. My parent functional group is alkane. So I'm going to take that A and E. Then my substituents are methyl and methyl. So it is a 3-methyl and a 2-methyl. So these become a 2,3 dimethyl. My backbone is heptane. So this molecule would be, when I bring these together, it becomes a 2,3 hyphen dimethyl heptane. That's what I expect you to be able to do on the quiz. I expect you to be able to do naming all of these molecules by the time of the exam. All right. Like I said, if you have any questions, let me know, and I will talk to you later. All right. Bye.